Solving a system of equations in section 1.4 deals with solving for an xy, or for example, solving for an xyz given 2 or 3 equations. So first of all, there are some terminology. It's inconsistent, which means no solution exists, and it's consistent if there is a solution when you look at those lines. Graphically, what that means is, just looking at the pictures, this would be consistent because it's the same exact line. This would be inconsistent, it's not intersecting, and this would be consistent because it is intersecting. I wrote up the solutions here because there's a lot of work involved, but you have to, when you have a problem like this, you want to find out what variable to eliminate. And I can see in here that my y's are the easiest one to eliminate compared to the x's and the z's. All I have to do is either add or subtract them. So I see that this is a plus and a minus, so I'm going to choose these two, add them, and get this equation, and everything's divisible by 12, so I divided 12 out. Then I took the first and the third one, because again I could add them and the y's would drop out. I get this equation divisible by 4 to get this. Notice that these two equations are the same, which means if I subtracted them, I would get 0 equals 0, and that means that there's an infinite number of x, y, z's that satisfy the system. That doesn't mean that you can plug any number in for x, y, and z and it'll work. It means that if you plug numbers in x, y, and z for one, that you will be able to have those same ordered pairs that would satisfy the others. The system of equation in this case, I'm going to see that I have an x, y, and z in the first equation. That's easy to deal with, so I'm going to multiply by 6 and subtract the two equations. Often when I subtract, I put parentheses down to remember I have to subtract each term as I go through to get this. Also, I multiply by 12 because I'm eliminating x's. And again, when I do this, I am going to subtract the second equation. So I'm going to get 0x, I'm going to get minus 36y. I'm going to get 6y, and then I'm going to get minus 36z. And then I'm going to get a negative 23, which is right here. Really easy to make a mistake on these. As you can see, I just stumbled there. But anyway, once you get this equation and that equation, I can multiply this by 2 and get my y's to drop out. And so then I multiplied it by 2, brought it over here, and now I can see I can just add down. Adding down gives me this, which means no solutions exist because 0 never equals a negative 39. The last example is this money one that deals with quarters, nickels, and pennies. Q is quarter, N is nickel, and P is penny. That means the number of pennies, quarters, and nickels. And so the first equation, I want to actually represent this in cents, 127 cents, because 25 cents of the number of quarters plus 5 cents of the number of nickels plus 1 cent of the number of pennies is equal to 127. This is the first equation. There is another equation that says he has twice as many quarters as pennies. That means to make that even, you need to multiply 2 by the pennies to equal the quarters. And we can represent that as an equation by subtracting 2p on both sides and remembering that they're still equals 0. The last one, 11 total coins, is what you see in that second equation. So what I'm going to do here is see that this doesn't have an n. So if I can eliminate the n here, I'll be left with 2 equations. So I'm going to go ahead and multiply the second one by 5. And I'm going to remember to subtract down. Put big parentheses down, show the subtraction, and when you do that, you get this equation, which divided by 4 gives you this equation. So at this point, I have two equations. I have this equation right here, and I have this equation right here. So if this is 1, this is going to be 2. And you're going to see that I'm looking at eliminating the p, so I'm going to multiply this by 2. When I multiply it by 2, I get this. And then again, what I want to do is subtract down. And when I subtract down, I get negative 9q. Those eliminate. And this is going to be a negative 36 dividing by 4. By negative 9, I get q equals 4. Now, if q is 4, I can see p is 2. So 4 quarters, 2 pennies, and then I stick them in the easiest one, which is this one, 5 nickels. This is easy to work with. The numbers are nice and clean. On some of those other story problems, there's going to be fractions, which makes this really difficult. Take your time, be accurate on every step, and it'll save you time in the long run.